Good afternoon, everyone. I welcome you all to this live session by Great Learning, and I'm glad that all of you are here on a Sunday to learn something. So before I start off, let's do the customary check. If you guys can hear me and if you guys can see my screen, just give me a quick confirmation. Just give me a quick confirmation in the chat if you can hear me and if you guys can see my screen. And also in the meanwhile, when you guys give me confirmation, I'd like to tell you that Great Learning has this free learning initiative called as Great Learning Academy, where we have almost 100 courses or more than 100 courses actually. And these all of these courses are with respect to different domains as you see over here. So we have all of these courses with respect to data science, ML, AI, cloud computing, big data, and a lot more. And once you complete these courses, you will get a course completion certificate. And you can go ahead and add that certificate onto your resume or onto your LinkedIn page. And that will be a huge value add to you guys. So the link for Great Learning Academy would be available to you in the chat. So someone from my team would be putting the link for Great Learning Academy in the chat. And also if you're interested to learn through an app, so I'm assuming that some of you folks would not have a laptop, and if that's the case, your learning shouldn't stop. So we also have the Great Learning app with us, and all of these courses are also available on the app. So you can go ahead and also download that. So on that note, we will start off with the session. And to all of the new folks who have joined our channel, if this is the first session on Great Learning which you're attending, I'd request you folks to hit the subscribe button and also click on the bell notification icon, as you will get notifications of all of these live sessions when we are taking. So please do subscribe and also hit the notification icon. And also you can spread the word of mouth about Great Learning to your friends, to your peers, to your colleagues. If they would want to upskill themselves in any of these domains, then they can go ahead and join our live sessions. If they, all you have to do is tell your friends to subscribe to our channel and they'll be able to attend all our sessions. And also I see that there's a watching of 78 and we have only 20 likes. So if we can quickly make it 73 likes in the next couple of minutes, that would be amazing. So all that you guys would have to do is click on the like button. So we have a watching of 73. Just get the likes up to 73. That would be wonderful. So on that note, we will start off with the session. So I just have a question to you folks. How many of you are Marvel and DC fans? How many of you have seen Marvel or DC movies? Or how many of you are comic book buffs? Let me know. And let me ask a controversial question. Are you a DC fanboy or are you a Marvel fanboy? So let's say if we have a battle of Batman versus, so Batman is DC, and let's take someone from Marvel. So let's say if we have a battle between Batman and let's say Captain America, who do you think would win? Let me know. And I want this session to be extremely interactive, so this will be a fun session. I believe most of you are, comic book fans. I myself am a huge comic fan, and I personally follow most of the Marvel comics as well as the DC comics. Well, we see that there are a lot of Marvel fans. Iron Man, Thor, Captain America, great, that's awesome. So in this session, we actually have a data set where we'll be analyzing the stats of a lot of DC and Marvel superheroes. So that will be interesting. Ramakrishna Narayan says Shaktiman. That's a wonderful answer, Ramakrishna. It's good to know. Well, we also need an Indian delegate in the superheroes franchise, isn't it? So, yep, Shaktiman, way to go. So So yeah, so on that note, so I believe most of you folks or some of you folks would be new to Python in general. So what I would do is give you guys a context of some of the libraries which we'll be using for today's session. And once we once we have a quick grasp on those libraries, we will quickly start off with today's session. So what we'll be doing today is we have a data set and we'll be performing some exploratory data analysis on that particular data set. And for that purpose, we will be using libraries such as matplotlib and pandas. So let's actually start off with understanding what exactly is pandas and why do you, how is it important in the context of what we're doing today. So now, if you have worked with, let's say, Excel or SQL, you would know the context of tables. What exactly is a table? A table is something which is represented in the form of rows and columns, isn't it? So, if you would want to work with a table in Python, then you would need to work with something known as data frames. And these data frames are provided by this library called as Pandas, which is the core library for data manipulation and data wrangling. And now, this provides you single dimensional data structure as well as multi-dimensional data structure. So when it comes to single dimensional data structure in Pandas library, that is known as a series object. And when it comes to a multi-dimensional data structure, that is known as a data frame. Now, we'll not be looking thoroughly into series object because that is not something which we'll be using for today's project. So I'll just give you a quick context of what exactly is a series object. As I've told you, it is a one-dimensional object which is provided by the Pandas library. And as you see, first, if you'd have to work with the series object, you would have to import the Pandas library. So you'll start off by writing import pandas as pd, and you will go ahead and create a series object like here. So you'll write down pd.series, and inside this you will pass in a list. What is a list? A list, you can consider it to be a collection of different items. So here we have a list which comprises of these numbers 1, 2, 3, 4, 5, and out of this list we are creating a series object and we are storing it in this object called as S1, then we are printing it out. Then if you look at the type of it, you see that this is a series object. So now what I'll do is I'll quickly open up Jupyter Notebook over here. So Jupyter Notebook is normally the IDE which I use to implement all of these all of these sessions. So you have a lot of IDEs to work with Python. So you have PyCharm, you have Spider, you have Visual Studio Code, you have Google Colab, you have Jupyter Notebook. And I personally use Jupyter Notebook a lot because for most of the data science or ML projects, I consider Jupyter Notebook to be much more easier to work with. So first we'll have to start off by importing pandas. So I'll write down import pandas as pd. Now I'll go ahead and create a series object. So pd is the alias which I've given for this library of pandas, and this pandas library has the series object. So pd.series, and here you'd have to remember that S is capital. Inside this I'll just pass in a list of values. So let's say it'll be 1, 2, 3, 4 and 5, and I will go ahead and store it in an object called as S1. Then I will print it out. And as you see, these are the values which we have, and these are the index values which are corresponding to these values which I've given. Now let's say if I actually change this, instead of 1, 2, 3, 4, 5, maybe I given 10, 20, 30, 40 and 50. Let me run this. Let me also run the cell. You would see that the values have changed, but the index values normally in Python, they start from 0. And let's actually see if this is a series object or not. So inside type, I will pass in the S1 object, and you would see that we have the result pandas.core.series.series, and this is a series object. Now, what we'll do is, that was a basic intro to series object. Now we'll actually see what exactly is a data frame. So as you see over here, a data frame is a two-dimensional label data structure. So again, a data frame, simply put, is just a table which comprises of rows and columns. And let's actually see how to create a data frame from a dictionary. Now again, some of you folks who are new to Python who do not know what a dictionary is, just consider a dictionary to be a key value pair. And you create a dictionary using these curly braces. So as you see over here, inside these curly braces, I have two key value pairs. The first key is name. For name, we have the values Bob, Sam, and Annie. And then for marks, we have the values 76, 25, and 92. So with these key value pairs, I'm creating a data frame. So again, data frame is part of the Pandas library. So I write down pd.dataframe, and here keep in mind that D and F are in capital. So this is, you have to make sure that you write it D and F, it is in caps and it is not in small case. Now here, if you will look at this data frame, you will see that the key has been turned into the column name and the values over here have been stored as the records. And this is how you can create a data frame using Pandas. Now let me go to Jupyter Notebook and just quickly create a data frame over here. So what I'll do is I will write down pd dot data frame. Inside this, maybe I'll give in so I'm creating a dictionary. Now instead of student and marks, what I'll do is maybe create fruits and the cost of the fruits. That would be interesting. So I'll have a key called as fruit, and let's say I have certain fruits over here, and let's say those fruits are apple, then I have a banana, then I have a mango. So this is my first key over here. Then I'll just put in a comma and let me give in my second key, which would be cost. Then I'll give in a colon. Now let me pass in the cost. So let's say apple costs around 12 rupees, banana costs 20 rupees, and mango costs 56 rupees. So these are just some random values which I've given over here. Now I'll go ahead and I'll store this in something called as a fruit basket, and let me print out fruit basket over here. And when I hit on run, you would see that the key over here has been turned into the column name. These values apple, banana, and mango have been stored as records. Cost over here is the column name. 12, 20, and 56 are again in the records over here. So this is a basic intro to Pandas. Now we will have to look at another library, which is matplotlib. So I'll quickly head on to matplotlib as well, and let me show you what that is about. So when it comes to data manipulation, you will use Pandas. Now, another important aspect of exploratory data analysis is visualization as well. And to visualize data which we have this wonderful library called as matplotlib, and that is the library which we'll be using over here. So as you see over here, with matplotlib, we can create all of these different geometries. So you can create a scatter plot, histogram, bar plot, and a lot more. Just to give you guys a context of how matplotlib works, I'll show you how to create a simple line plot. Now, there is another library in Python which goes by the name of NumPy, which NumPy is basically, it stands for numerical Python, and it is used for most of your numerical and scientific computation. And here we are importing NumPy using this. So we write down import NumPy as np. Then we would have to import this submodule called as pyplot from matplotlib. So we write down from matplotlib import pyplot as plt. So this is the alias. PLT is the alias which I've given for pyplot. Then I go ahead and create some data over here using the NumPy library. So arange is a method which comes under the NumPy library. And what I'd want to do is I'd want to create a NumPy array which has numbers starting from 1 going on to 11. And in np.arange, you'd have to understand that the first number which we give is inclusive, the second number which we give is exclusive. This would mean that when I give in 1 and 11, I'll have all of the numbers starting from 1 but only going on till 10. So let's say instead of giving 1 and 11, if I given 1 and 10 over here, then the numbers would go from 1 to 9. So this is how I'm creating the object X over here. Then I'll go ahead and create the object Y. So Y is 2 times of X. So basically in X you have 1 to 10. Then in Y you have the value starting from 2 going on till 20. And to create a simple line plot, all we have to do is write down plt.plot, and inside this we will pass in X and Y. So X goes on to the X-axis, Y goes on to the Y-axis, and as you see on the X-axis we have value 0 to 10, and on the Y-axis we have the value starting from 2 going on till 20, and this is a very simple line plot which we have created. So I'll just add a comment over here which would be visualization, and let's just import the two libraries. So I'll write down import numpy as np. Then I would also need matplotlib, so I'll write down from matplotlib import pyplot as plt. So these are the two required libraries. So these two have been successfully loaded. Then going ahead, I'd have to create the data first. So here X is equal to np.arange. So let's say on the X-axis maybe I have the value starting from 50 to 100. So this is what I'll have in X. Then Y, let's say, is 3 times of X. Let's actually make it 3 times of X. Now let me print out X over here. So X has the value starting from 50 to 99. Y has the value starting from 150 to 300. So again, as you see over here, so this is basically 3. So 50 into 3 becomes 150, 51 into 3 becomes 153. So that is how these numbers are progressing over here. Now to make this plot, all I'd have to do is write down plt.plot, and inside this I will just put in X comma Y, then I will just show it out to you guys, which will be plt.show. And as you see, this is the very simple line plot which we have created. X-axis goes from 50 to 100, Y-axis goes from 150 to 300. So this is a simple intro to the libraries which we'll be using today. Now let me quickly head on to the chat and see if there are any more questions. And guys, keep putting in your questions in the chat. I want this session to be as interactive as possible. So please keep posting your questions. Akash Gandhi is saying, could you please make a full video on exploratory data analysis, including how to handle outliers, fill null values, and all the concepts? Sure, we will keep that in mind, and either we can come up with a video on it, or we'll have a live session sometime on it. So sure, we will keep that in mind. Vignesh Pal is asking, is this a Hindi session? No, this will be in English. So we also do sessions in Hindi, but then again, if you want to know when the Hindi sessions are coming up, you can just go to Great Learning Academy over here. So you would see all of these live sessions are lined up. So as you see, so we have a live session in Hindi tomorrow. So this is Linux for Beginners in Hindi. So if you want to know when the live sessions are, just go to Great Learning Academy and you will find the schedule of our upcoming live sessions. Tirath is saying Shaktiman is above them all. Absolutely. So seems like we have a lot of Captain America fans over here. Captain America, Iron Man, Marvel, Batman. Great. Shefali is asking, how can we set maximum features according to length of data? Could you elaborate the question, Shefali? So when you say maximum features, is that with respect to machine learning, or is that with respect to exploratory data analysis? So also when you say 5 lakh data, do you mean that if a data frame has 5 lakh records, or does it have 5 lakh columns? Priyanshu is asking, is this Python series for beginners? No, this is not the Python series for beginners. The Python series is done every Tuesday and Thursday, and that is in Hindi. Right, so we have done 2 sessions till now, and if you'd want to attend those Python in Hindi sessions, those are conducted every Tuesday and Thursday 4 p.m. So you can definitely attend those. Manas is asking how to download Jupyter. It's extremely simple. So Jupyter comes along with Anaconda. So what you'd have to do is go to just write down Anaconda over here. So you see Anaconda, the world's most popular data science platform, and here you have commercial edition, team edition, enterprise edition. Let's actually go to individual edition over here because this is what we'd want. And when you click on download, you have so again, since Python is platform independent, you can work with Python whether you have a Windows system, a Mac system, or a Linux system. You can you can download Anaconda for any of these operating systems. You just download this, and once you download this, Jupyter comes pre-installed in Anaconda. So this is how you'll get it. Right. So on that note, we have had a basic intro to the libraries, and I've also looked at a couple of questions in the chat. Kitu was asking what to do if Pandas and Anaconda did not show run in Jupyter Notebook option. There might be some instances where the installation is not proper. So what you'd have to do is just again go to Anaconda over here. So you have your Anaconda prompt. Just write down pip install pandas, and this is how you'll be able to install any of the libraries. If you'd want to install matplotlib, just write down pip install matplotlib. So this is how you'll be installing any of these libraries in Python. But then again, if you install Anaconda, all of these libraries come pre-installed. So you don't have to do the groundwork over here if you have Anaconda with you. And that is why I actually prefer working with Anaconda and Jupyter Notebook. So on that note, we will we will start off with the main part today. And also guys, we have a watching of 85 and we have only 67 likes. So we would need as many likes as we have watching. So if you could quickly make that 85, or if you can even get that up to 100 likes, that would be amazing. So quickly go ahead and hit the like button. And on that note, we will start off with today's session. So as I've told you, we'll be working with these 2 libraries. We will not actually require Seaborn. So Seaborn is also another visualization library, which we will not require today. So I'll just delete it from this command. So we would need Pandas. The alias for Pandas is PD. We would need PyPlot, which is a submodule in Matplotlib. And I'm giving this an alias of PLT. Again, let's just wait for these libraries to load. So that is done. What I'll do is I'll actually remove the results from over here so that it will be much more interactive, so that you actually know what is happening over here. Now, let me start off by running this again. And now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the Pandas library, and we have a CSV file called as character stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default this head method gives you first 5 records which are present. So as you see, this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abinser, Abomination. Then you have the alignment, whether the superhero is good, or so basically we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So I guess there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abinser, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now going ahead, I'd want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that, so out of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains, and 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. Rakhi Gurjar is asking me to repeat. So could you tell me what exactly do I have to repeat? Rakhi is saying PLT is not defined. Have you given the exact command over here? This is what you'd have to give from matplotlib import pyplot as PLT. If you're given the exact same command, this needs to work. And if you haven't, then maybe there might be some installation issues. So you just have to install matplotlib by going to Anaconda and writing pip install matplotlib. So that should help you out over there, Rakhi. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. So let me explain this command properly to you folks. So what I'm doing over here is, so first, when I given the name of the data frame, inside this I given the column name. So let me write down alignment over here, and when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here, and if we go up, so we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now when I hit on run, and if you look at this particular data frame over here, so you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only, so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again here, you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why you have 3D man at the top. Now, I'd want to see which of these superheroes has the maximum speed. So, speed over here is a numerical column, and if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good.sort values, and I would want to sort this data frame with the help of the speed column, and I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have this speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to again store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell above this, and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3 and 4. So again, so you have different versions of Flash over here on the basis of the comic book. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd similarly, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1, and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Wizkid, Wandra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good dot sort values. So I'll delete min speed good, and over here I'll also delete this. So now from this data frame good, I'd want to this time, so initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good dot sort value, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. What do you guys think about that? So now, similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power, and I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame, and I will store in, let's say, I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here. So let me just good max powerful. And when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually see. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V dot shape. And when I hit on run, so you would see we have 33 superheroes who have a power of 100. And that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Where was that? Sort values, speed. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so seems like Superman does not have a power of 100, so that is something interesting to find out over here. So I'll quickly head on to the chat and see if there are any more questions. Diya Banerjee Das is asking, is the value count method case sensitive? Yes. Python in general is case sensitive, so you'd have to keep in mind that anything you're typing out in Python, it has to be case sensitive. Jeevan Sharma is asking if it has any missing value, what do we do? So right now it does not have any missing value, so we'll not really look into that. Mohit Joshi in 33.9, what is 9? 9 is the number of columns. So in 33.9, 33 is the number of records and 9 is the number of columns. So folks, put in your questions over here. I'll keep taking up your questions in between. Mohit Joshi is asking, false means bad or neutral. So what we were doing is, the condition which we gave was something like this. Where was the condition? Marvel.shape. Right. So here what we are doing is, wherever, so this is the condition which you give. So if this condition is met, if the alignment is equal to good, then you'll get a true value, else you will get a false value. That is how it works. Vinita is asking, if out of those 611 heroes, if we'd want to check out anyone specific, so you'd have to give in the exact name of him. So let's say if I want to check, let's see, who do we have over here? Let's actually check Thor. So if I want to check only the record of Thor from this entire data frame, what I'll do here is, I'll write down, I'll give in the name of the data frame, which is good. Then I have a column called as name, and what is the name of the superhero? It is Thor. And this is what I'll do. This is the condition, and again I will keep it in the good data frame. I'll put it inside this and I'll hit on run. So as you see over here, I have extracted only this particular record where the name is Thor. So this is how we can analyze some specific records from the entire data frame which we have. So we have done analysis till till the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again we will be needing matplotlib, and matplotlib again has a submodule called as pyplot, for which we have given this alias of plt. Now I will insert a cell above this, and what I'd want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power, so you see this total column over here. So I'd want to look at the top 5 list of top 5 list of those who have the maximum total value, right? So here as you see, Martian Manhunter seems to be he seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. For in all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. So this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here, and these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions. And I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8,5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these 3 different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5, because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again 0 to 5, because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have done. Siddharth Chandal is asking, can you please give a short intro on what does Panda do? So I've done this in the start of the session. So if you have joined in late, maybe once the session is done, you can go back and quickly check it out. What is Pandas, and how are we doing all of this? And guys, for those folks who have just joined in, I'd request you to subscribe to our channel and hit the bell icon. So we'll be doing a lot of these sessions on a regular basis, and also we'll be uploading a lot of tutorials. So if you're interested in data science, data analytics, machine learning, AI, or maybe other domains such as cloud computing, DevOps, so we have tutorials on all of these different domains, and we keep uploading them on a regular basis. So please do subscribe to our channel, and please do hit the bell icon, so it will give you regular notifications, and also it will encourage us to come up with more such live sessions. Siddharth is asking, if the graph is 5 cross 5, why are we specifying 8,5? These are the dimensions, Siddharth. So this is not actually 5 cross 5. Let's say if I change this to maybe 10 cross 5, you will see that the dimension will change. So as you see, 10 over here is for the, what do you call this? So this is the width, and 5 over here is the height. Now let's say if I change this to maybe 10 and 2, let's see what will this look like. So as you see over here, so again we have changed the figure size over here. If you just want it to be maybe 5,5, keep it 5,5 over here. So again, so as you see, 5,5 doesn't really look that great, so I've given 8,5 over here so that these bars are more spaced out. So I hope that answers your question, Siddharth. Amar is asking, can we get the code in the data set? So someone from my team would have posted the link for the code in the data set, so you will be able to get that over there. Right. So guys, also quickly, those folks who haven't yet subscribed to our channel, quickly subscribe, and also if you haven't yet clicked the like button, please do like it, as this will this is how you can show your appreciation to us. This is how you can show your love towards us if you like the session. So please do like the session. And we have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time, from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or supervillains: Ammo, Amazo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these supervillains. So again, it will be bad dot sort values, and this time by it will be speed ascending is equal to false. So similar stuff what we've done, and as you see over here, so you see that a lot of these supervillains also have a speed of 100. So you have Zoom, Airwalker, you have Amazo, you also have General Zod over here. So then you have Superboy Prime. So all of these supervillains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run, and as you see over here, you have Mr. I'm not sure how do you spell this, but so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing. Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most badass of all of these supervillains. So again, I would want to look at the total column over here. So bad dot sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amazo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that how Doctor Strange, who is equally intelligent as Dormammu, who is able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 10,5. I don't know, 10,5 seems fine. plt.bar. So someone in the chat has asked how to give different colors in the bar. So I'll show you how it's done. So plt.bar, here the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 superheroes for which, 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here, and I have plt.show. Why do we have an error over here? Bad max power. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So I hope that answers your question, Venkata. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram, and here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now on the other hand, if I just want a distribution of speed, so speed is only a numerical column, that is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. Alright. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have two peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for super villains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to super villains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. So this was all about the exploratory data analysis for the Marvel and DC superheroes. Let me again come back to the chat and see if there are any more questions. Neeru Gupta is asking if there's a Blender tutorial. So right now, I believe we do not have a tutorial on Blender. So again, we'll keep that in mind, and we will come up with a session on that soon. So also, if you have any requests on what we are supposed to take up, please put them up in the chat. So let's say if you like this session and if you'd want to learn more, then let us know in the suggestions. So, we can, if we look at those suggestions and if it is something our team can take it up, we'll definitely have a live session or a video on it coming up. So this will be it from my side, and if there are any final thoughts or any final questions from you guys, please go ahead and put them up. I'll just wait for a couple of minutes or so that you can put in your final words, final suggestions or questions. Viplav is asking, will this class remain here or not? Yes, this class will remain here. So whatever live sessions we take, those are available on our YouTube channel. Pinkita is asking us to make a video on scopes. Sure, we will take that up. Mohit is asking, what if I need only some selected columns as an output, not all columns? Sure, I will show how to do that. So let's say from the original data frame, which is Marvel. Now I'll write down Marvel. From the Marvel data frame, if I'd want only the name column and the total column, so this is how I'll do. First, I'll give in this column, the name of this column, then I'll give in the name of this column. Then maybe I'll store it in a new object and I'll call it as Marvel total. I'd have to give in 2 braces over here. Let me cut this out. Let me paste it inside this. Now let me print out the head of this. So it will be Marvel total dot head. And as you see over here, I have extracted only 2 columns from the entire data frame. So you just need to give in the name of the data frame, and inside the parenthesis, you need to give in 2 braces over here, and inside those 2 braces, you need to give in the columns that you'd want to extract. Santosh Kumar is asking, what were these superheroes doing in the pandemic? Interesting question, Santosh. So maybe I guess they were following the lockdown protocols. Who knows? So I guess even superheroes were staying at their homes. You don't really know. So I guess on that note, we can end this session. Thank you very much for attending, and hope to meet you in future live sessions. And again, on that final note, if you haven't yet subscribed, please do subscribe to our channel. And also, before leaving, just hit the like button, and have a good day. Have a great learning ahead. Thank you very much for joining, guys.